Hey all, it's Miss Johnson, back at it again with some calculus. This is the video for the area between curves assignment, right? I'm going to go over the process. I am going to go over the notes that we should have, and I'm going to start being aggressive about actually having those out. And then we're just going to do two problems that look like the last two problems on the assignment. If you have additional help that you need, you can come on Wednesdays, so today, from noon to 2:30, and any day that you have calculus, you can come on the last half of the hour slot. So to be honest, if you're confused, just message me on Teams, at me in the chat, and I will tell you, yes, this is a great time, or we can make a time where you can come. That's going to be the process until we really get the schedule figured out. But again, always reach out, right? Over Teams message is best. All right. The process for finding the area between curves is basically three steps of setup and then one step of actually doing some calculus. The setup is we need to find the points of intersection between the two lines we're finding the area of, right? That's going to be the A and the B for our integral. We need to graph these equations so we can designate a top and a bottom function. That's going to be these two functions, right? Then we need to set up the actual integral. The actual integral will be the top function minus the bottom function, and we integrate that over the interval from A to B, where A and B are where these two curves cross. And then I'm going to talk about it something a little bit at the end where that might be confusing. But for now, that's it. That's that for that. And then the step 4 is actually taking the integral, right? This is when we use our notes to find the antiderivative, where we plug in the top and the bottom bound and we subtract those numbers. So we actually get a number as an answer. So number answer. That's a good note to have. Great. That process is going to be in the notes. I'm going to post these on Schoology. When we're doing the problem, I've got a little tiny version of the process here. But really, a clutch thing is I'm also going to post these notes, right? This is when we're taking the antiderivative in step 4, what it is, right? The kind of sub units that we have here are the power rule. So when the exponent is a number, we use this rule. The exponential rules. So when the exponent is a function or an x, we use this rule. Whenever the answer is log, it's the answer, or sorry, the question was 1 over x or a number over x. Seems kind of good. Trig, where the answers are basic, right? Where cosine, sine, tangent, cotangent, secant, and cosecant are our answers. And then the trig rules, where we've got basic questions, where tan, cotangent, secant, and cosecant are our questions. That's like the biggest tongue twister for me. But our answers are kind of complicated, right? Here, sometimes our questions are complicated, but that's that for that, right? So when we come across these in the wild, we now know we're good. In our notes, we should also have the use substitution stuff, but this assignment doesn't use it, so I'm not going to put it here. But this is something we'll add in a later assignment, or in a previous assignment, to be honest. But here we go. All right, let's try it out. Let me move this as far away as I can. All right, that's fine. So if we wanted to find the area between this parabola and this line, we would use this process, right? 1, we find the intersections. 2, we'll graph it over here. And then 3, we'll actually do the integral. So let's section off my work. Okay, to find the intersection between these two curves, I'm going to do this one algebraically. I'm just going to set them equal to each other and solve for x, right? The first thing I'm going to do is FOIL out this x plus 4 squared. And I'm going to subtract 6 and add x to both sides to make this equal to 0. So again, what I just did there is I FOILed this out. FOIL. Wow, not even close, y'all. FOILed this out, and then I moved these to the other sides. Now I'm going to combine all my like terms. I've got an x squared. I've got plus 9x. I've got this is going to be 8. And now I'm going to factor this. I want things that multiply to 8 but add to 9. And then when I set each of these equal to 0, I get that x is -1 and x is -8. I then could plug these into either of the original equations to get the actual coordinate of the intersection rather than just the x value. But to be honest, I don't even need the coordinates. I just need the x value. So these become a and b on our integral. Okay, 2, we're going to graph these. Again, I'm doing this one by hand, and I'll do the next one with Desmos. Actually, I'm going to use Wolfram Alpha because it's a better website, but here we are. But I'll do this one by hand. We want to graph these two to find which one's the top and the bottom. I'll make this one red. I'll make this one blue. Blue is, I hit at 6. I also hit at 6 here. It's just a straight line. And then blue or red, I go over 4, down 2. That's my vertex for a parabola that looks like this. You might say, Miss Johnson, how did you know that it hit up here? I plugged in 0 for x and got that this was going to be 14, right? Let's extend this blue one. We already know that they intersect at -1 and at -8. You see how I use purple for the intersection because red plus blue is purple? I'm an artist. And then we'll fill in this as the area we're looking for. All right, so step 1 done, step 2 done. Step 3, the setup. We haven't done it yet, so let me show you. The setup is we put the integral from -8 to -1 of the top function. I forgot to designate top and bottom. The blue one's obviously on top. So we're going to do 6 minus x minus the bottom function. The red function is clearly on bottom. And dx. We have now set up our function. I didn't write it here, but it's very important. We should have parentheses around these, right? I want this to distribute to all of these correctly. And so to do that, we need to make sure that those parentheses are around our top function and our bottom function. Great. Now we actually do some calculus, right? We are going to simplify this, right? I'm actually going to do out this algebra. It turns out this is -x squared minus 9x minus 8. Miss Johnson, how'd you do that so fast? You're a wizard. No, I just did it over here, but knew that instead of moving the 6 minus x to the other side, I'd be moving the quadratic to the other side. But also you can just do it out again. And now we use our notes, right? Now we use our notes to find f. Whenever we have a multi-term function, we're going to do all of these as their own little integral, right? -1 times x squared becomes -1 divided by 3x to the cubed. I used the red power rule here because my exponent is a number. I moved my exponent up by 1 from 2 to 3. I divided my old coefficient, -1, by the new exponent, 3. I'm going to do that again. I'm going to move my exponent up by 1. I'm going to take my old coefficient and divide it by my new exponent. That's how I get that the integral of -9x is -9 halves times x squared. And then -8 becomes -8x. I get that from my fun example, which is when it's just a number, it just becomes the number times x. No plus c here because it's a definite integral. So instead, I'm going to remember the negative, remember my bounds. I'm then going to plug this into a calculator. I'm going to plug each of these into my antiderivative, right? So I'm going to say this is -1/3 times -1 cubed minus 9 halves times -1 squared minus 8 times -1 minus all of that, but I plug in -8 instead of -1. So let me copy paste, take advantage of the fact that we're on a computer. Right, so these ones are all -1s, and these ones are all -8s. I'm going to plug that into a calculator. And to be honest, I have already plugged it into a calculator. Bingo bongo. It's 57.16. So this is 57.16 forever. Right? So this is my area. Feeling good. Number, answer, I did these things, we've solved it. Great. We're done. Let's do this again, but with maybe a slightly more complicated one because it's trig. I like trig, but that's just me. 2 and then 3. Let's find the area between cosine and x squared minus 1. On your homework, it's sine, but it's going to be pretty similar, right? Number 1, find the intersections. I'm going to go to wolframalpha.com, and I'm literally going to type in the words intersection of cosine and x squared minus 1, right? And then I'm going to scroll down, and I'm going to see it's at these 2 points. Great. X equals negative 1.765 and 1.765. Done. That's my M by B, right? If I want to, I can already plug these in down here just because I know that these are going to be here. When you're plugging in your intersections, the bigger number is always on top and the smaller number is always on bottom. If you flip these, your answer will just be negative, right? So if we had put negative 8 on the top here and negative 1 on the bottom here, we would have gotten negative 57 as an area, and we would have said, ooh, we did something backwards because areas are positive numbers. All right, number 2, let's graph this. Again, this is the computer version, so I'm just going to go on Wolfram Alpha and say graph of these 2 things, or to be honest, the graph's right here. So I will call cosine red, I'll call x squared minus 1 blue. I will draw in cosine first because I like it better. And it's first. Boom. And then this comes down about right here. Right? These go forever like a snake. And then our intersection points are again at negative 1.765 and at 1.765. This designates our red as our top function and our blue as our bottom function. So, boom. For our setup, we do the top function, which is cosine, minus our bottom function, which is x squared minus 1. Hopefully you see the value of these parentheses or these brackets. It's kind of choose your own adventure. It's just aesthetic. They're the same exact thing mathematically. Because now when we write out the simplified no parentheses version of our integral, we get cosine of x minus x squared minus a negative 1, which means it's plus 1. And we need to really make sure that this becomes a plus 1 or our answer is going to be wrong. Okay, we integrate cosine. When we find the integral of cosine in our notes, we get sine. Amazing. So down here we just write sine of x. The integral of negative 1/2 or x to the 1/2 is 1/3 x to the 3rd. We use the power rule, the red function in the notes. And then plus 1 just becomes plus x because numbers are just the number times x once you integrate them. We keep track of our boundaries. Bingo bongo. And then we plug each of these boundaries into our function. So first we've got sine of 1.765 minus 1/3 1.765 cubed plus 1.765. And then we subtract the same thing, but we plug in a negative. Right? It's like negative, negative, negative. Right? Again, this is a calculator situation. I'm not sitting here knowing these questions, knowing these answers. So I've plugged it into Wolfram Alpha here using just an absolutely ridiculous amount of parentheses just to make sure it's right. And we get 1.82. 1.82. There we go. We have now solved it. We got a number answer. So these are the things you're going to be doing, right? The notes, you can screenshot them right now if you want to. You can also look them up on the video and class notes section of our Schoology page. I'm going to go ahead and save this right now so I don't forget. Bingo bongo. And yeah, again, if you need any help with calculus, if you're feeling stressed, message me on Teams, right? I will either tell you this is a great time to meet or tell you when is a great time to meet. All right. See y'all in class.